Hello everyone. Now I will introduce how to use BrainCog to implement a deep reinforcement learning method based on spiking neural networks. We propose a spiking decode model in this paper. Brain-inspired spiking neural networks have been successfully applied to many pattern recognition domains like image classification, target detection. However, the application of deep SNs in reinforcement learning tasks is still a problem to be exploited. In this week, we mathematically analyze the problem of the disappearance of spiking signal features in SDK and propose a potential-based layer normalization method to directly train spiking DeepQ networks. This is a spiking DeepQ network with potential-based layer normalization. The framework is in Fig 2. This is a same network structure as decoding 3 layers of convolution and 2 layers of fault connection. Neural model in the spiking Q network is adapted from liquid, integrate, and file model. One of the most important factors of hiding the application of SAN in DRL is the disappearance of spiking firing activities in deep spiking convolution neural networks. We found that spiking neural firing and spikes vanish rapidly, and the deep layer of SANs are very prone to no spiking activity. This problem makes the deeper SNs lose signal features in information processing. In this work, we propose a potential-based layer normalization method. Normalization to solve the spike activity vanishing problem in SDK. We apply the normalization operations method on post-synaptic potentials in convolution layers. The effect of normalization on membrane potential is when the spiking signal of the previous layer is input, the membrane potential begins to rise. Comparing with the leaf model, neurons with function of normalization are affected by neighbors and can holding the membrane potential values so that the neural firing a spike as long as it receives little input in the future. This puts the neuron in a easy-to-fire state when it can process long-term interval signal and reduce the loss of features when passing on the input information. We compared our model with the decode model and the ASN conversion-based decode model. The performance I got on 16 other games. The PLS decode model that we proposed achieved better performance compared with original decode and conversion-based decode models. Okay, we applied the SDK model in the BrainCog uses examples and implemented the spiking decode model in the network passing files. It implemented the spiking neural network module and the normalization module in this class, in the spiking decoding class. So if you want to reproduce experiment in the paper, you can only need to run the main passing file and to complete the this will to complete the training and testing process of the SDK model on the other game. This may take several days depending on the hardware specifications on which the experiment is run. While the boy is also introduced to the uses of BrainCog to implement the spiking neural network and apply it to deep reinforcement learning tasks.